One, I request all the dignitaries to come on stage right now. Ladies and gentlemen, distinguished guests and esteemed colleagues, a very warm welcome to the 12th lecture of the Professor EGR Distinguished Lecture Series, proudly organized by the Department of Metallurgical and Materials Engineering, IIT Madras, in collaboration with the Indian Institute of Metals. We once again welcome all of you here with us and also those joining us live online. As we gather here today for yet another edition of the Professor EGR Distinguished Lecture Series, I can't help but reflect on the immense joy it brings to all the metallurgists out here. This annual event has truly become a festival for our community, a celebration of knowledge, innovation, and camaraderie. I want to take this moment to express my heartfelt gratitude to everyone who has contributed to the inception and continuity of this lecture series, which we have conducted since 2013. Your unwavering support and dedication has been instrumental in making this event a resounding success year after year. And today marks the 12th lecture in our series, a testament to the legacy and the relevance of this series. But before we dwell into today's lecture, I feel compelled to share a few words about the man behind the name, Professor E.G. Ramachandran, fondly known as Professor EGR among his students and colleagues. Born in 1925, his journey has been nothing short of extraordinary. At the tender age of 19, with a recommendation from none other than Sir C.V. Raman himself, Professor E.G.R. embarked on a remarkable academic journey, earning his PhD from the University of Sheffield at the age of just 22. Such was his brilliance that the university had to actually revisit its rules to validate if they could give a PhD to someone this young in age. Truly, he was an exceptional individual. And as we gather here today, let's honor the memory of Professor EGR and reaffirm our commitment to upholding the ideals and the values that he stood for. But before we proceed with the agenda for today, let's begin with a moment of cultural reverence. I invite everyone to join us in the Tamil Thai invocation, followed by the singing of Vande Mataram. Thank you so much. We may please be seated. As we embark on this enlightening journey of knowledge and discovery today, let's take a moment to acknowledge the remarkable lineup of events that have been scheduled. To kickstart the proceedings, I would like to invite to the stage Professor Subramania Sarma, Head of the Department of Metallurgical and Materials Engineering, IIT Madras, and Chairman of the Professor EGR Distinguished Lecture Series Committee, to extend his warm welcome to all of us.
Good afternoon, friends. It's a great privilege for me as head of the department to welcome all of you, especially our director, Professor Kamakoti, our speaker, Dr. S.V. Kamath, and Satish Pai, Managing Director of Hindalco Industries, and of course, our distinguished alumnus as well. Professor B.S. Murthy, currently director, of course, our colleague, and Professor Kamraj, my colleague in the department, and Professor O. Prabhakar, former colleague, and family of Professor E.G. Ramachandran, online and offline. And all of you, I am extremely grateful for joining us today in this very important annual event, which we department is very proud to conduct, conceptualized by Professor Murthy and students of Professor EGR over the last 12 years. And we are happy to have all of you here. As I see, is a very important topic, especially in the current geopolitical situation we are in, that the defense R&D, especially for in the context of India. And I'm extremely eager to looking forward to the thoughts and ideas that Dr. Kamath is going to share with us. And we hope as Metallurgical Engineering Department, we hope that some of our colleagues will be contributing to these important areas of research. And we will hope to take it forward to the development of the nation as well as our department. Thank you.
Thank you so much, sir. We now have the privilege of hearing from Professor B.S. Murthy, Director of IIT Hyderabad and convener of the Professor EGR Distinguished Lecture Series Committee, who will provide us with insights into the lecture series now.
Good afternoon, friends. First of all, my apologies for not being there physically, and please forgive me for that. This is a lecture which is very close to all our hearts, everyone who is associated with metallurgy, particularly with the IIT Madras Metallurgy Department. And our Master of Ceremony has already spoken about Professor EGR to some extent at the age of 22, where most of us join for PhD typically, and Professor EGR has got his PhD at that age. And as she rightly pointed out, the university had to seriously think how we can give a PhD to such a young person, and then had to change their rules to finally give him a degree. And from then, Professor EGR went to IISc Bangalore, spent about 9 years there, then moved to NML and spent about 5 years as assistant director, where he actually wrote 2 Nature papers from sitting from NML. I met to see a metallurgist from India writing Nature papers. So that's something which is very amazing. In those days, he was able to do it. And then he moved to IIT Madras in 61. Then from then until 85, when he retired, almost 25 years, he has served IIT Madras. And he was the first professor and first head of the department of IIT Madras. And he was known to be a great teacher. And every one of them who was a student of him talks a lot, including Mr. Muthuraman used to talk a lot about his, you know, teaching capabilities. And in fact, Mr. Muthuraman once told all of us that just after finishing BTech, when he was about to leave to US to take up a PhD position, and he met him to just convey this message that I'm leaving India. And he said, we want people like you to be a part of Indian industry and lead the Indian industry. And then he decided to stay back and join Tata Steel. So he remembers that particular meeting of him with Professor EGR. Such kind of personalities who can inspire you so much that you completely change the course of your whole life and take up something else. And that is a kind of caliber of this man whom we are talking about. And he was also very well known in the field of metallurgy, particularly industrial metallurgy. He was the one who started industry metallurgy wing in IIM, okay, and then finally became the president of IIM in 1980. So that's all about Professor EGR. That a little bit that I know. I had wonderful meetings with Professor EGR all those years, and all this started. This particular lecture series started with a meeting of one Mr. Pukraj. I don't know whether he is able to sit. He's in this particular meeting today. It must be really midnight for him in US. But he met me in January of 2013 when he was visiting India, and he said, "I want to do something for my guru, and I want to give 5 lakh rupees to you. Can you please think of starting something?" And that is when I talked to my departmental colleagues, and all of them were very eager to start a lecture series. And then after him, the two of his daughters contributed, Lakshmi Chandra and Paru. Both of them contributed to this. And Professor Muhammad Roshan also contributed. Srikanth from NML also contributed. And Professor Dasaradhi, another student of Professor EGR, also contributed. With that, we got approximately about 12.5 lakhs of rupees. That is what was the kitty that we have created. And that has been the one which is making this lecture series continuous. And many stalwarts have contributed to this lecture, starting with Professor Ranganathan, my own guru. And then second lecture was Muthuraman. Then the third one was Professor Deepankar Banerjee. And then Padma Shri Krishnadas Nair gave the fourth lecture. Then Professor Opabhakar, I heard that he is sitting in the audience. He gave the fifth lecture. Professor K. Padmanabhan gave the sixth one. And Professor Sundar Rajan from ARCI gave the seventh. And Professor Mansoon Reddy, DMRL director, gave the eighth one. And Professor K. Narasimhan from IIT Bombay gave the ninth one. Then our Suresh Babu from University of Tennessee gave the 10th. The 11th was our Bala, whom we fondly call him Bala, the current director of DMRL Hyderabad, and the current one, the 12th one. We are really fortunate that Dr. Samir Kamath has agreed to give this lecture. So as you can see from the luminaries who have been giving this talk, and that tells that this particular lecture series has really been valued a lot by people, and we are really fortunate to have got great people sharing their ideas in the field of metallurgy and material science to the large gathering, and ensuring that the knowledge of metallurgy spreads to everyone around us. So that's the basic brief of how this whole lecture series started, how it is going on. We have a committee for this lecture series. This committee every year selects the speaker, and then we approach the speaker, and once the speaker gives his or her consent, we continue with the rest of the procedure. Thank you very much for the department, for the institute, and for IIM Chennai chapter, which has been giving all the support that is needed for running this particular show for the last close to 12 years. And thank you very much for this opportunity that Professor Sharma has given me to speak a little bit on this particular lecture series. Thank you very much. Once again, apologies for not being there physically.
Thank you so much, sir. We are now privileged to have Mr. Satish Pai, Managing Director of Hindalco Industries, President of the Indian Institute of Metals, and a distinguished alumnus of IIT Madras, who will now share his remarks on this occasion.
You are muted, Satish.
Yeah, sorry, I had muted when you were speaking. So thank you very much for giving me this honor of saying a few words today. As you rightfully said, Professor Muti, this series of special lectures is indeed a platform to commemorate stellar contributions to the science of metallurgy. And the Indian Institute of Metals, of course, is very happy to be associated with this. Today's special lecture pays tribute to the late Professor E.G. Ramachandran, as many of you have already said, an extraordinary teacher, visionary, and an academician par excellence. I think during his 3-decade tenure with IIT Madras, Professor Ramachandran shaped the Department of Metallurgical Engineering and positioned it as a leading institute for metallurgical education and research. It's very clear from listening to you that he has inspired generation of metallurgists. His students are the torchbearers of his teaching excellence. Professor Ramachandran was also instrumental in founding the Department of Industrial Metallurgy at Indian Institute of Metals and served, as you said, as its president in 1980. I am also extremely delighted to announce that my colleague and fellow IIM Apex Council member, Dr. Samir Kamath, a distinguished scientist, will deliver today's lecture. Dr. Kamath, as he himself says, a blue-blooded metallurgical engineer, I think his notable contributions to the field of metallurgy have won him national acclaim. And I'm sure that his lecture on defense R&D, the road ahead, will provide valuable insights and hopefully will inspire young members of the Institute of Metals, IIT Madras, metallurgical engineers in general to explore new areas in R&D and innovation. So with that, thank you very much and really looking forward to the lecture.
Thank you so much, sir. Now I have the honor of inviting our esteemed chief guest, Professor V. Kamakoti, Director of IIT Madras, to share his valuable thoughts and insights with us.
Friends, students, I request the students to come to the front. All students, can you just move to the front? Thank you. At the outset, let me extend my very hearty welcome to Dr. Kamath, Samir Kamath, who is the Secretary of and Chairman of DRDO. Friends, metallurgy has become the most important topic today. They say it's the equivalent of 2 countries possessing nuclear bombs. If you have certain rare earth, which the other country is dependent upon, then it actually settles the balance. So rare earth has actually become a very, very interesting and important supply chain issue. In this context, there is a tremendous need across the country. It's just come up in the last 4 or 5 years, amplified by COVID, that we need to have a lot more of expertise in getting these metals, getting these things processed, making it marketable and whatnot. And in this context, the role of all these metallurgy departments across the nation is extremely crucial. In this context, I must, as the director of IIT Madras, I'm very, very thankful to Professor EGR for being the first founding head of this very illustrious department, which today is in the brim of doing very cutting edge work, both in the materials and metallurgical engineering. I'm sure that over a period of time, the department will become one of the most attractive departments. I come from the computer science. I hope the JEE toppers take up metallurgy. That's my very important and very, a big wish. Because when we look at the type of jobs, the type of opportunities that are in front of us, I think metallurgy will give a much more stable job than the AI and ML job, which your computer science colleagues get. I fondly remember Murthy once called me and said, Kama, you're blessed. I said, why? He says, I go to my class, everybody is sad they didn't get computer science. Then I told, even I have the same thing. I go and ask. My boys say, I didn't get computer science, IIT Bombay. And in IIT Bombay, there's only one fellow who's happy who's the AR topper. All the other people are sad that they did not get AR1. So this goes on, right? But I think that days are gone. I think metallurgy is becoming a very, very important field. I hope none of you ask for, I don't see any BTechs here, but I think you should encourage the BTechs to come for these type of lectures. And MC is a BTech and you're not asking for a branch change. Okay, good. And today's lecture had a lot more value. Thanks to Dr. Kamath for coming here, accepting our invitation. He's going to talk about the opportunities in DRDO. Defense is very important consumer and a very important funding agency for a lot of metallurgy related research. Everything that you touch, right from small bullets to tanks to whatnot, satellites, missiles, everywhere metallurgy will play a role. Even this mic, there is a metal here. Okay, so I think we should acknowledge that fact. And I wish that all of you take a lot more inputs from this lecture, and let us see a good set of startups coming from the metallurgy department. So Pradeep, Fani, Kamraj, Sharma, look at me. So all of us, let us all work together to get a very good set of startups who can address very important aspects of metallurgy. I just came to know from a fellow who is refining gold. He says there's not a single person who can guide him in refining gold. He has to go abroad to refine gold. That's what he said. I don't know. I hope it is false. But then if it is true, then we are in a very bad. So we should get, I have been telling to make this more attractive, we should start an MTech in jewelry making. I think fashion jewelry. I think that's a very important concept. And now lab-grown diamonds are coming up. Let us see. So there's a lot to work. So I'm sure this lecture is going to open up certain very interesting things that you can follow. And again, thanks to all the family of Professor EGR. When we are standing today, the eight consecutive years we are rated NARF1. All these have come because so many people have contributed to the development of this institute. And in that, I'm sure we hold Professor EGR in very great respect. So thanks. I think we have Professor EGR's son-in-law and daughter, Ms. Lakshmi has joined. So we fondly remember, the department fondly remembers. And I've also seen the total number of people who have joined online for this particular lecture. Thank you very much, sir, for accepting, Dr. Sami. And we look forward to your advice to our young budding PhD and MTech and undergraduate students. Thank you.
Thank you so much for the wonderful message, sir. Next on our agenda is the introduction of our distinguished speaker. Please join me in welcoming Professor M. Kamaraj, co-convener of the Professor EGR Distinguished Lecture Series Committee, to introduce to us our esteemed speaker for today's session.
Good evening, everybody. Respected dignitaries, online and offline. It is my honor and privilege to welcome you to the 12th lecture of Professor E.G. Ramachandran Distinguished Lecture Series. Also, I'm delighted to introduce today's speaker, distinguished speaker of this evening. Dr. Samir Kamath is currently a Secretary, Department of Science and R&D, and Chairman of DRDO. Dr. Kamath completed his BTech honors in metallurgical engineering from IIT Kharagpur in 1985 and PhD in material science and engineering from the Ohio State University, USA in 1988 and joined DRDO in 1989. Dr. Kamath has provided leadership and direction to several critical materials program in DRDO, such as the development of high-strength steels for naval ship applications, development of high-temperature titanium alloys, nickel-based superalloy-based components for aero engine specifically, and the development of tungsten heavy alloys for kinetic energy penetrators, development of fused silica radar domes for missile seekers, and armor applications for personnel as well as the combat vehicles, and stealth materials for airborne and naval applications. These have found use in various systems in being developed by DRDO laboratories. In addition, he has spearheaded the development of naval systems such as advanced lightweight torpedo, anti-torpedo decoy systems, autonomous underwater vehicles, advanced hull-mounted and towed array sonars for ships, and fuel cells-based air independent propulsion systems for submarines. Dr. Kamath is a fellow of Indian National Academy of Engineering and Indian Institution of Engineers, India. He is a recipient of Distinguished Alumni Award from IIT Kharagpur, Metallurgist of the Year from Ministry of Steel, and Scientist of the Year Award from DRDO. He has published more than 180 papers in international peer-reviewed journals. And without taking much time, once again, I thank you for joining for this meeting. And I look for Dr. Samir to deliver his distinguished lecture. Thank you.
Thank you so much, sir. Before we commence with the lecture, I would like to welcome our dear director, Professor V. Kamakoti, to felicitate our esteemed speaker with an Angavastram, symbolizing our respect and appreciation for him. Thank you so much, sir. And now is the moment we have all been eagerly awaiting. It is with great pleasure that I invite Dr. Samir Kamath, Secretary of DDR&D and Chairman of DRDO, to deliver the much anticipated 12th lecture of the Professor EGR Distinguished Lecture Series.
Thank you, Professor Kamraj, for the introduction. At the outset, let me wish all of you a very good afternoon. And I'm indeed honored to be given this opportunity of delivering the Professor E.G. Ramachandran Memorial Lecture. So I would like to start by paying my respects to Professor Ramachandran. Although I didn't have the opportunity of knowing him, his contributions are well known, and as was described today, he was truly a visionary and a great leader who has helped in setting up this department in IIT Madras and produced students who have gone on to produce great wealth for the country. So with this brief homage to Professor Ramachandran, let me come to today's lecture. The topic I've chosen is Defense R&D, the road ahead. And as Professor Sharma mentioned, we are in a very interesting phase in geopolitical developments in recent years. So to set the stage for my lecture, let me start with what the current situation is. We are moving from a unipolar world with US domination to a multipolar world where India is also going to play a big role. The rate of change of technology also is accelerating significantly. Earlier, most technologies were being developed over a 10, 15-year time frame. But these days, technology changes are so rapid that if you don't deliver a system with that technology within the next 4 to 5 years, your systems become outdated. There is also emergence of several disruptive technologies, AI, ML, quantum, autonomous systems, which are driving huge changes in the way wars are being fought. I think the recent examples of Ukraine, Russia, Israel, Hamas are a living proof that unless we change the way we have been working, we won't be able to rise to the challenges that are going to emerge soon. Earlier, the wars were fought on land, air, and sea, but now the domains have expanded to cyber, space, and information. In fact, cyber warfare is a continuous war. It's even happening. India is one of the most attacked countries when it comes to cyber. The warfare is changing in the sense that it is becoming network-centric. So your sensors everywhere are connected. In real-time, information is being passed on to your platforms, which deploy weapons. So the transparency in the battlefield is becoming very high. So unless your platforms are capable of avoiding this, it is very difficult for them to survive in the current battlefield. Platforms are that's why becoming autonomous, where you don't have humans involved, where risk to life comes down. And increasingly, instead of bombing randomly, you are having precision strikes. So you need systems which can deliver your warhead to very precise locations so that you don't cause collateral damage. So the nature of warfare is changing. The geopolitics is changing. And we all have to take cognizance of this fact and prepare ourselves if we have to survive and meet the challenges. In addition, our Honorable Prime Minister has given a call for Atmanirbhar Bharat and Make in India. This has really given an impetus and a momentum for not only making defense systems and technologies within the country, but also in promoting R&D within the defense sector. Our Honorable Prime Minister has also set all of us a target that our country has to become a developed country by 2047. And not only a developed country, but to become a leader in technologies, which includes defense technologies. So with this background, it is important that we plan our R&D, especially defense R&D, to meet the aspirations of the country as well as the changing geopolitical scenario. So if you look at the present defense ecosystem, defense R&D is mostly done by DRDO and supported by academia and MSMEs. The design and development of systems also happens mostly in DRDO, though things are changing now. HAL is making helicopters. Some private sector companies have also started design, but still it's in the nascent stage. And finally, the production happens in PSUs or private industries based on TOTs either from DRDO or from abroad. So this is the current defense ecosystem. It is not that this defense ecosystem has not delivered to the nation. So let me highlight some of the things which this ecosystem has made our country proud. So you can see here, pointer, no problem. As you see here, new generation surface-to-surface missiles, cruise missiles, smart airfield weapons, surface-to-air missiles, air-to-air missiles, anti-radiation missiles, anti-tank missiles, multi-barrel rocket systems, all have been indigenously developed and inducted or soon to be inducted in our services. Similarly, a variety of armored vehicles and land systems, which includes the MBT Arjun, which was developed by our laboratory CVRD in Chennai. We have also developed a wheeled armored platform and several bridges, as well as a variety of mines and other systems. As I said, a variety of artillery, guns, and ammunition have also been inducted based on indigenous R&D and production. Aerospace also has been an area of success. You must have heard of LCA Tejas. We have also soon, the first flight of LCA Mark 1A production version has just taken place a month back, and LCA Mark 1A will also get inducted into the Air Force soon. We have developed a LCA aircraft which is capable of landing on the aircraft carrier, which is a major challenge which has been overcome. And although this aircraft will not get inducted, but the technologies which have been developed during this technology development project are going to lead to a twin-engine deck-based fighter, which we are going to take up soon. We have also developed an airborne early warning and control aircraft, which has the sensors, which gives you a transparency in the battlefield. 2 of these systems have been inducted, and the third one is getting inducted soon. And we are now in the process of starting development for a similar platform on a much larger aircraft, which will give higher ranges and help our Air Force in combating our neighbor to the north. A variety of unmanned aerial vehicles have been developed. To name a few, Rustam 1, Rustam 2, Black Kite, Imperial Eagle, Panchi, Nishant. And as I mentioned in my opening remarks, unmanned platforms are going to become extremely critical in the future battlefields, whether it's in the air, whether it's on land, or whether it's underwater. I can proudly say that the country today is more or less Atmanirbhar when it comes to radar systems. We have the capability to develop any type of radar, whether it is land-based radars, ship-based radars, or airborne radars. And a variety of radar systems have already been inducted in our services. The same is the case with electronic warfare systems. As I said, the battlefield is becoming very transparent. If you don't have a good electronic warfare system, it is extremely difficult for your system to survive today, because the electromagnetic spectrum is being fully exploited to detect anything, whether it's in the sky or on land. So you need a very good electronic warfare system to counter this. And I'm proud to say that our laboratories have delivered world-class EW systems to our services. Communication systems are critical, as I said. If you want network-centric operations, you have to be able to communicate. So we have worked on software-defined radios for our airborne platforms, for our ships, as well as land platforms. Data links for our unmanned systems, as well as data links with satellites, is another area where we have achieved full competence. The SATCOM terminals and hubs, which are critical, as I said, space is becoming an important zone if you want to fight a battle. It allows you ability to do surveillance over a much wider area than what is possible from the ground. And you have to be able to communicate that information back to your platforms. Naval weapons and systems, which include torpedoes, underwater mines, anti-torpedo defense systems, have been developed and inducted. Sonars, which are required to detect underwater threats, they have also been developed. And a sonar development also involves development of various technologies, including transducers and acoustic materials, which can help you in detecting submarines. So variety of sensors, devices, and advanced electronics have also been delivered. I will not get into the details here, but just to apprise you that this is one area where we need to improve. I would not say that we have achieved full Atmanirbharta here. We have done a lot, but a lot more needs to be done in this. Soldier support is being done by our life science laboratories to make a life of a soldier easy in the battlefield. As you are aware, our soldiers have to fight in the deserts. They have to fight at high altitudes, which poses several challenges. And our laboratories have developed various soldier support systems to enable them to undertake these tasks. So now let me come whether the defense ecosystem which I mentioned, where you have applied R&D, design and development systems by DRDO, basic research by academia, and production by industry with very little overlaps. Is that an optimal system? Because we have to admit that although we have delivered systems to our services, we are not the technology leaders. We are still chasing technology. We are still chasing systems. And if we have to meet our Prime Minister's target that we have to become technology leaders, we have to change the way we have been working. If we don't do that, it is unlikely that we will meet the goals that he has set us. So what you need here is basically an overlap between the academia, DRDO, as well as industry, happening much more than what it is happening today. So DRDO, we have a limited manpower. We have about 7,000 scientists currently. So it's not going to be possible for DRDO to take up every possible system which is required by our services. So it's going to be increasingly important that the design and development also happens much more than what it is happening today. You would need industries to take what are known as upgradation of existing systems, incremental advances which happen in systems have to necessarily be taken up by industry so that DRDO can focus more on futuristic systems and technologies. We need far more innovation by startups and MSMEs, because startups and MSMEs, being small, have more flexibility. They can change directions much quicker than larger organizations. And we have to encourage far more participation of startups and MSMEs in our defense ecosystem. Although startups are becoming now very common in our service sector, I think the number of startups in the defense ecosystem are quite limited. Although space now is attracting a lot of startups, we are hoping that similar spurt happens in startups participating in the defense R&D. Academia also has to expand its scope. And we had a meeting today in DIA COE in IIT Madras, and I was quite impressed with the kind of projects which now the academia is taking. And I was very happy to see that academia is working closely with DRDO labs as well as industry to take their R&D, which starts at a low TRL levels to a very high TRL levels. And this is a trend, I think, which is extremely good and necessary if we have to meet the requirements that we have set for ourselves. One of the problems that we have faced in this country in our R&D is we have not set up enough test facilities and infrastructure. And these test facilities and infrastructure have to be set up before you take the R&D. Otherwise, it becomes very challenging to test whether the technology or system that you have produced meets the requirements that it needs to before it is delivered to the services. We tend to make the full system and then test it rather than test each subsystem. And that can be done only if we invest in infrastructure. Capacity building, and I'm happy to see several students here. We need to build capacity in R&D. We need more students to get into doing masters and PhD and contribute to original research. We can't just be followers of what others have been doing. We need to do more original work, and that can only happen if we have larger capacity and better skill set within our students. As I said in my initial remarks, disruptive technologies are giving an asymmetric edge to whoever develops them first. So we not only have to worry about these new high-end technologies, we also have to worry about how we can use even existing technologies in a disruptive way, which can give an edge to our services. As you would have seen, Hamas has used very low-end technology, but in a very innovative way to cause severe damage to Israel. And you are seeing the Houthis of Yemen causing the entire shipping from Red Sea using simple drones and low-cost missiles. So we have to look at innovating before others do, because it's in the surprise element that you get this advantage. And we have to change our mindset that we will only do what others have done. And the youngsters here have to play a key role there. Because the older you become, you get set in your ways, and your thinking also gets constrained by the knowledge you have. And you assume that this is the only way of doing things. So it's young people like you who can really help the country by thinking originally, thinking innovative. And there is far greater need for civil-military fusion. For long, it was the military technologies which used to drive the civilian sector. But in recent times, that has flipped. In a lot of areas, it's the civil sector which is now driving technologies. And the military is far too resistant to change to drive new technologies into the system. So we need a way in which the technologies which have already been developed for civil sector, how they can get incorporated into defense. So we need far more civil military fusion than what we have in the country today. And today's meeting gave me a sense of satisfaction and sense of confidence that that may happen soon. So in DRDO, we have been trying to see how we can adapt to this changing environment. Earlier, as I said, we used to develop the technology, we used to make the system, and then do a transfer of technology to an industry. But in the last 3-4 years now, we are involving the industry right from our inception of our design and development project. And we hope that by this, not only will the industry absorb the technology better, but they would then also be able to do all the necessary upgradation and incremental advances in those systems, freeing up DRDO scientists to take up more complex systems and technologies. We have made our IPR policy simpler. We are giving our intellectual patents, intellectual property rights free to all industries. They don't have to pay us. We are also doing transfer of technology to our DCPP at no cost, and we are also giving technologies to other industries at fairly low cost. We have started a fund called Technology Development Fund, where we can fund up to 50 crores for an industry to take up R&D on their own. And initially, these were meant for doing indigenization of existing systems or components or subsystems which were in use in the services. But we are now expanding this scheme to take up really cutting-edge projects. We hope to get that done soon. There was a committee headed by Dr. Kakodkar and Dr. Saraswat, which have recommended that in such type of projects, even if you get a success rate of 20%, similar to what happens in DARPA projects, audit will not come chasing after you. So hopefully this scheme will be implemented soon, and this may help us in at least achieving some successes in some critical technologies and systems. We have started a Dare to Dream innovation contest where we throw up challenges where individuals as well as startups can participate, and the winners are then funded if they are interested to carry forward their idea into a realizable product. And we have also opened up our test facilities for industry at a very nominal cost. They can come and use our facilities to help them in their R&D. Unfortunately, our defense topics are not taught in most academic institutions. For example, armaments, missiles, which are specific to defense requirements, are usually not taught in university curriculums. So we have started now with Ministry of Education a program where PhD students can come and work in a DRDO laboratory on DRDO's problems. We have also introduced MTech in defense technologies in 40 AICTE institutes. And we are trying to work to see if we can introduce some elective courses in a BTech curriculum, which will then help us in producing a suitable capacity to undertake defense projects in the future. So we also increasing the number of internships we offer to BTech, MTech and MSc students in our laboratories. And we have now paid apprenticeship schemes to build skills at the technician levels also. So as I said, our wish is that the incremental advances and the conventional systems will be done by industry. And DRDO's focus will shift to next generation complex systems and technologies. So the advanced medium combat aircraft, which is a 5+ generation stealth aircraft, has just been sanctioned by the government. And over the next 10 years, we hope to get it inducted into our service. And as I mentioned, the twin engine deck-based fighter, we hope to get it inducted into our Navy by 2030. We are also looking at a UCAV, a remotely piloted stealth aircraft for our future needs. We are looking at high altitude, long endurance UAVs, autonomous underwater vehicles with very high endurance, unmanned ground systems, robotic soldiers. As I said, the warfare is becoming increasingly autonomous. You want to avoid, loss of human life. You can take a lot more risks with autonomous platforms. So that is the direction in which we are also headed. So all the technologies which are necessary for autonomy are a focus area for us. If you look at futuristic weapons and sensors, we are looking at hypersonic, glide and cruise missiles. And if you have to deliver such missile systems, you have to look at scramjet technology. You have to look at ultra high temperature materials which can withstand the high temperatures which will arise when these missiles have to fly through the atmosphere. We are looking at very long range air-to-air missiles because increasingly you need higher standoff distances as your transparency of the battlefield increases. It's going to be very challenging for your aircraft to get into enemy territory. You need to be able to fire these missiles from well within your territories. So you will need much longer ranges in your air-to-air missiles. As I said, very long-range radar. These are requirements for space situational awareness. As I said, space is the next frontier in the battlefield. And you would need to have an idea of what satellites are traversing over your paths, what missiles are coming towards you much before they come close to you where you need to intercept them. So this very long-range radar technology is going to be very critical for the country. Aero engines is one area where we have worked for the last 30, 40 years. But although we have developed a Kaveri engine, which has delivered a thrust of about 70 kilonewton, it did not meet the requirements of LCA. So we had to use a GE engine in our aero platform. But this is one technology where we have to deliver. Otherwise, our dependence on foreign engines is going to haunt us in case we have to fight a prolonged war. So this is one technology. An aero engine technology involves manufacturing technology, materials technology, as well as the design, which requires CFD and all other types of mechanical expertise. And the real challenge in aero engine technology is that you operate at temperatures which are above the melting point of your turbine components. So there is very little margin for error. So if your design is off even by 5–10%, your engine performance or engine safety itself becomes critical. So it's a real challenging technology, but this is one technology which the country has to master going ahead. Coming to new and critical technologies, I think AI, ML, everyone is aware of, so I will not speak about it. But quantum technologies is one area where we are, I would say, only 3-4 years behind the rest of the world. Quantum sensing, quantum communication, quantum materials, all are areas which we need to work on to make sure that our military has the edge. And post-quantum cryptography is another area. As your quantum computers become more and more powerful, all your encryption is going to get into trouble. So we have to look at how we can master post-quantum encryption necessary. Otherwise, your communication, your data, all are going to get intercepted by your enemies. Stealth and anti-stealth technologies are again going to be very critical, as I kept saying in my initial remarks. The electromagnetic spectrum is being tapped to the maximum extent. And unless you have this multispectral stealth, your survival in the battlefield is going to be very limited. Robotics, directed energy weapons, and I'm glad IIT Madras is working with us closely in not only making the sources, but in combining these sources to get very high powers, which is necessary if you want to damage airborne platforms or even satellites. Compound semiconductor materials and devices. Silicon is a boat that has sailed, though now the country has woken up and we have trying our best to catch up, though it is going to be challenging. But compound semiconductors is still an area where we can be competitive. So gallium nitride technology, silicon carbide technology, gallium oxide, and various IR-based materials. This is an area where we need to focus and achieve leadership. And advanced materials and manufacturing. I thought since this is a materials audience, I will spend a bit more time. But before I do that, let me also highlight that within the DRDO system, we have started 5 young scientist laboratories where everyone, including the director of the laboratory, is below the age of 35. And we are hoping that these laboratories will be the equivalent of startups within the DRDO ecosystem. And we have given them the freedom to interact with other startups as well as academia. And we are hoping that these will help us, these 5 labs, and we are planning to increase the number of laboratories, will help us in driving innovation much faster than in our bigger laboratories, which the bureaucracy tends to stifle innovation. So we are hoping that these young scientist laboratories will be the nuclei for our transformation into a more innovative organization. So now let me come to advanced materials. Materials technology underpins almost all defense systems and is a key enabler for significant advances in the performance. For example, if you want to have a submarine which dives to greater depths so that it doesn't get detected, you need a steel which can withstand, so that depths, as you go down, the strength required for the structure to not collapse. It needs a higher strength. It needs a higher impact toughness. But you have to achieve this without compromising on the weldability, because submarines are huge structures. You cannot build it without welding. And as you are all aware, metallurgy students must be aware, one way of increasing strength of steel is to increase the carbon percentage, but then the weldability comes down. So you have to be able to design a steel which has carbon percentage below 0.1%, but still achieve high strength, high toughness, good weldability, good corrosion resistance, if you want to design a submarine which can go to higher depths. If you want to build a kinetic energy penetrator, you need to design a tungsten heavy alloy, which has high density, but good enough impact strength that it does not break in the barrel because of the forces it encounters in the barrel. So as I said, materials technology is a key technology if you want to get significant improvements in the performance of your defense systems. So there are a variety of materials which the defense systems use. I will not get into the details of each of them, but if you are a metallurgist or a material scientist in IIT Madras or any universities, the scope is enormous. You can work on any type of materials of your interest. And if you are able to achieve a breakthrough, it is going to help defense R&D in a big way. But there are some challenges when it comes to doing materials for defense. One is the low and sporadic volume. The other is the stringent qualification and certification requirements. When you make a material for a civilian application, you don't have to go through the kind of qualification and certification which you need to do if you are doing a material, especially for aeronautics or for underwater application. And one of the challenges is the material development cycle is far too long. Today, it takes anywhere between 10, 15, 20 years to develop a new class of materials. As I said, the cycle time is shrinking when it comes to defense systems. So we have to find better ways. Can we speed up material development? And can we try to compress the development cycle, which I will address in my future slides. The other challenge is that designers expect that materials in all forms are available. So it is not good enough to just develop a material in your laboratory. Unless you are able to translate it to an industrial scale, convert it into different product forms, the utilization of your materials is going to be limited. So a lot of times, though the knowledge exists, the material does not get translated into an industrial form. So though the material scientists, metallurgists are happy that I have made this material, if I am a designer, if I am a designer of a defense system, for me it is of no use. Unless I have a material produced at industrial scale with enough data available for me to have confidence in the properties that you are claiming that your material has, it becomes a futile exercise if I am the designer. For a material scientist, you are very happy that you have produced this material at lab scale. So this aspect has to be looked at seriously. So as I said, this 15 to 20 years is not just within the country. This is a slide which I have taken from Robert Shafrick from GE Aircraft Engine. As you can say, that even to modify an existing material for a non-critical application takes 2 to 3 years. And this is because of the certification and qualification requirements. So this is one challenge for all young metallurgists and material scientists who are here. can you find better ways of reducing these timelines? Then you do a great service, greater use of newer materials in defense systems. I'll skip this. So as I said, the system design and development cycle far outpaces the material development cycle. So today what happens is, if I'm a designer of a defense system, I only use a material whose properties are available in a database. I will not come to a materials developer and say, can you develop me a material which will be suitable to meet all my design requirements? I would go use a ASM handbook, or I will use other databases and take only those materials which are industrially available, where property characterization has been done statistically, not just one or two values, which doesn't help the designer. He needs a statistical variation in your strength, in your toughness, so that he can design appropriately. So that is why insertion of new materials is becoming a challenge. So we as a materials community have to rise up to this challenge. So ideally, a situation should arise where the design team talks to the materials team, and the materials team also then talks to the manufacturing and systems integration team. And within the time frame of the development, if the materials team is able to not only produce or develop the material, but also produce it to meet the requirements of the design. Although it is easier said, the challenge to do this is the predictive computational materials engineering models are not available other than for very few materials due to the complexity and variety of materials and physical phenomena. As a result, this has not happened, but I'm happy to say that with ICME and a materials genome initiative, which has started in the early 2000s, this has started in the US, but now is spreading across. Using this systems level approach to materials design, optimization, and implementation, where you use computational tools, experimental tools, as well as your digital data, there is a possibility that we may be able to cut down on the materials development time. I think the current targets are 7 to 8 years, but I'm sure as we progress, we may be able to cut it down to 5 years. But in the country, we need to do much more. IIT Kanpur has started a ICME center, but I think more universities have to take the lead and invest in both the computational tools, but also using AI/ML techniques to see how we can speed up or extract information from the vast data which we have already generated in the last 70 years in this country. So basically, as I said, the material development continuum is a linear process. And using these computational tools, we have to make it a non-linear where all activities can happen simultaneously, which can help us then bring down the development time. So this linear chain has to be broken. There has to be far greater interaction between academia, R&D labs, as well as the industry. We have to first do a lot of computational based processes and then take up, once you have optimized, then only do the linear chain. So there are a lot of challenges. As I said, Our mindset has to change. There is a culture shift required in how we do materials research, development, and deployment. We also tend to work in silos. The experimentalists collaborate with each other. The theoreticians and the computers modeling people tend to talk to only each other. We all need to talk outside our silos. We have to make a headway in this ICME, MGI kind of environment. Access to digital data is another problem. Especially in defense, we are very cagey about sharing any data. Our services are even worse. But unless data is shared, maybe with some security, I think we won't be able to use the models or algorithms that we develop more effectively. And of course, the curriculums in prestigious institutions like IIT Madras, they have to address these needs going ahead. I'm not saying you need a whole-scale change in your curriculum, but you have to make sure that students get exposed to these new methods of material development so that they are well trained when they join industries or R&D institutions in the future. So with this brief interlude for the materials community here, let me get back to defense R&D. So we have identified as DRDO's 75 priority areas, which we have further then broken into technology categories. And you don't have to read this here. It is available on our website. So whoever wants to pursue R&D can look at this and then frame your problems, and DRDO will be glad to fund you. We have also started 15 centers of excellence in different academic institutions, and one of them is in IIT Madras, and we had a governing council meeting today morning. And in each of these centers of excellence, we have identified some key research verticals. It is not that a faculty member has to work only on the verticals which are mentioned against their academic institution. So this is a hub and spoke model. One center of excellence will be a hub, and then the spokes can go to other institutions. But our objective of building these centers of excellence, which we are calling DRDO Industry Academia Centers of Excellence, is to build an ecosystem like MIT and Caltech did in the US to promote innovation and development of critical technologies. So we don't want these centers of excellence to be doing just projects for academic interest. We want these centers of excellence to have a goal in mind, which may not be achieved in one project, but as a combination of projects, eventually we have to reach a certain goal. And we are quite sanguine that in 5 to 10 years, these centers of excellence will give us good dividends. I can already see, based on today's review, that the projects which are being undertaken are now really yielding dividends. So I'll not get into the details of these. As I said, one of our focus areas is now also setting up these critical test infrastructures. We have set up a hypersonic wind tunnel test facility. We have a seakeeping and maneuvering basin facility, an aeronautical test range where people can test their drones and UAVs, an open test range, Orange, where you can measure the radar cross-section of various platforms. We have also started an extreme altitude research center in Changla, which is at an elevation of 17,800 feet. As I said, our neighbor to the north is really troubling us. So we need equipment which can handle the high altitudes and low temperatures. So we have a test center where you can test your system. And as I said, we are opening up all our test centers to academia as well as industry. And if you develop a system, you can come and use these test infrastructures to test your systems. So I have presented you a picture on where we need to go and how we need to do it. But there are still some issues which we need to address as a nation. If you look at our R&D spend and compare it with other countries, we spend only 0.65% of our GDP on R&D, overall R&D, forget defense R&D. And if you see the other countries, they spend more than 2%. So if we have an ambition of becoming a technology leader, we have to increase the R&D spend. This has been discussed in various forums, and I think now the government also is realizing that it is important to invest in R&D. The R&D is an investment. It doesn't give immediate returns. And pretty hopefully, the target set is that we should reach 1% of our GDP by 2029. That is the target the government has set for itself. So good times are ahead, I hope. And if you look at even the defense R&D budget, our R&D budget is about 5% of our overall defense budget. And if you look at US, China, they spend close to 10 to 15% of their defense budget, which is already larger than ours. So if we have to compete with them, either we have to look at innovative technologies or we have to increase our defense R&D spend. This again, the government is now taking note of, and they are now increasingly willing to fund industry, though there are still pockets of resistance to fund industry for R&D. Mindsets are changing. But I think one thing which needs to happen is the industry also has to fund R&D. That has been a problem in the country. Industry is very reluctant to fund R&D. They expect only the government to fund all the R&D. So both a change in mindset from the government to increase R&D spending and a change of heart from our industry to not only look at technologies which are ready-made and available off the shelf, but to invest in R&D. But the biggest problem which I think which we have to overcome is aversion to risk and intolerance of failure. We expect that every R&D project should succeed. One reason is, especially in the government system, we have the CAG who comes and then says you have caused infructuous expenditure to the government. So that's why we are averse to taking any risks. We fund only incremental advances where the risks of failure are less. But then this is a vicious cycle. Everyone talks of DARPA and how DARPA has transformed R&D defense in the US. But the success rate of DARPA projects are 10 to 15%. We have to be able to take those kind of risks. But DARPA is backed up by Congress, where they have an oversight in terms of the efforts put, but they have a freedom to fail. So we need a similar mechanism, and which would require change in our GFRs, which we have been telling the government that if you really have to become a technology leader, we have to look at our GFR processes. Hopefully, I'm an optimist. I hope that in the years to come, this will happen. And that will really give a fillip to our ambition and dreams of becoming a technology leader. So finally, to summarize, Achieving Atmanirbharta and technology leadership in defense technologies by 2047 is definitely possible, although challenging. Thank you for your kind attention.
Thank you so much, sir, for this mind-boggling lecture. We've truly gotten many insights on the R&D and the road ahead in the defense sector. Following the lecture, we now open mics and invite questions from the audience to engage in a discussion.
You talk about DARPA. I think much of the world's technologies have emerged from there. I don't think India can be left behind in this area because we have really done a phenomenal work in creating technologies over a period of time. But I think there's a mindset change that's required. And that's not it's a revolutionary mindset change and not an incremental mindset change. Because unless you move faster than everybody else, I don't think you'll ever catch up. So that's, I think, certainly something that needs to be looked at very carefully. There needs to emerge as somebody. I fully agree with you. A part of my job is to drive this mindset change, though it is very hard.
Thanks a lot, Dr. Samir, for very motivating talk for youngsters. So one of the points that you brought in, and that's what we are also struggling to see that how it can be done, is this whole digital data. So from both point of view, can we accelerate this process? And I see challenges already. So for example, you said that, of course, being defense, you do not want to expose what you intend to do even, let alone tell others that.
A lot of times it is not required, but we hide behind that.
Right. So, okay. Even that could be the case, right? Not even that it is required from someone, but we still don't do it.
Yeah.
So, is there a way to make that more and more accessible, that whatever information could be provided, should be easily available? And I see the challenge. So we ourselves are trying, we started with this question that as simple a question as this, that every year there are at least tens of thousands of publications are done on battery material. Everybody is publishing. Can I go and search that in this class of material, who has performed the best? And you will never get the answer. You will never get the answer. Every person publishes in a way that it's very hard to compare this publication to that publication. So we are addressing that challenge right now. We are developing a database so that we come up with a common framework which actually can capture all the publications that are possible. But on a similar side, is there an effort being made so that our students, for example, they know, okay, this is what exactly DRDO wants. These are the specifications they will like to have. That could be implemented as a submarine, or it could be implemented in a missile, or it could be implemented in a tank. So is there any effort where they become aware that, oh, yeah, these are the standards DRDO is looking for. So let me check if my material, which I have developed with hard work during PhD, can that meet even those expectations which DRDO might have?
Correct. Currently, it's not there, but it's a good suggestion. We will try to. I think Director DMRL is online. Maybe it's a challenge you should pose him, because he's aware of most of this requirement. So we have our materials laboratories, which can then help all other researchers in setting the benchmarks what are necessary.
That might tell them that this is what I have to achieve. I may not have that, or I need to go there. But
as I said in my talk, just producing it in the laboratory doesn't help anyone. It's a good step, but it has to be then continued. So you have to work closely then with the R&D lab and then an industry to produce it at an industrial scale. Then only it helps a design.
So in this effort, sir, if you tell that this is the requirement and this guy somehow sitting somewhere in a corner of a lab tells that, look, at least one more aspect of this, I'm But you said that not only once, but consistent.
Correct.
A lot of the times, our
Correct. You
poor-
get a property once or twice, you are happy. In a laboratory, you are very thrilled. But the designer, unless he has a statistical variation, can't use it.
but our poor guys get so
Correct.
much of access to equipment. they
I
can't
agree.
have,
I
Right.
understand
So-
your limitation. I was in your shoes also.
So if they can also upload this and say that this is available, so both sides, if that availability of information would be there, that would be something that would.
I
take into
fully agree with you, but the flow of information somehow doesn't happen. It needs to happen much more than what it is happening. I fully agree.
So Bala here, sir. May I add?
Yeah, please.
Yeah. So I think just to add to that, definitely there is no disputing what has been talked about. And like you said, the real challenge is, of course, changing the mindset. And the other thing is to decide in the beginning itself what can be shared and what need not be shared. And then the other thing is consistency and reliability, and also the necessary data and parameters that need to be known. But definitely, if we can have a more structured way of sharing, or even the policy that will facilitate sharing, not just across the board, but even within labs and so on, it will definitely help. So I think maybe we may have to form a task force or something just to look at digital data and how we can move it forward. So if you can think along those directions, maybe it might help, sir.
The task force was formed under INA. I think Funny was also a part of it. But somehow it has not gone further than just making a report. We are good at making reports. We are very bad at implementation.
That is true. Thank you.
Yeah.
Sir, I am Dr. Prashant Kumar Padi from Rourkela Steel Plant, Steel Authority of India Limited, sir.
Yeah.
Am I audible, sir?
Yeah, you are audible.
Sir, I have two issues, sir. Presently, we are facing. Balasab is here also. We are jointly working together. Actually, we are producing two materials, special materials for one, that is for defense grade, DMR grade, sir, that underwater applications, and other is armor grade. For defense grade, sir, it is a 1969 best plant. So we are producing special special steel, DMR grade steel for underwater application. We are facing a difficulty for many things like challenges, webinars, and other things. We are testing challenges we are facing. So to cater to the certified products for this underwater applications, sir. So how to cope up these times, sir? Actually, the demand and presently a lot of demand is there. We are going for the S5 level that submarine, sir. So for that thing, we are producing materials, and it is going through a stringent testing cycles. So we are facing. So it needs upgradation at the industry level. So that is one part. To cater to the services requirement of the project Akanksha. That is one. And second is we are getting for armor grades, we are getting some critical orders, like say some like T7, T90 tanks, we are getting some awardee, heavy vehicle factory awardee, we are getting certain order, like buffalo plate for fuel tanks. We are getting to supply the metal very that a component testing they are asking, and here we are testing. So that is a long cycle to establish the material characters. So we need what sort of support can be provided so that material property can be established here, and we can forecast that this can help at the customer end.
Yeah, as I said in my talk, supplying to defense is not easy because of the
Yes, sir.
qualification and certification requirements. So
Yes, sir.
a lot of investment is needed in your equipment, in your plant, in your quality processes, if you have to meet the.
Sir.
But one limitation which may not be there for the steel which you mentioned is the volumes are low. In this, the steel which you mentioned, at least there are sufficient volumes. But in a lot of materials, the volumes are low, especially during the development phase, the volumes are extremely low.
Yes, sir.
Only if the equipments which may not be dependent only on the material, only if that equipment passes all the tests, only then does it get inducted, and then only you will get orders, which the time frame is quite long. So these are
Yes.
challenges which there are no easy answers. So
Yes, sir.
defense R&D, defense production, being in the defense sector itself is a long-term game. You cannot
sir.
have a short-term mindset and succeed. You have to be in the game for the long term. You have to invest in your equipment. You have to invest in in-house R&D testing, and then hope for the best.
Yes, sir. A lot of patience is required, sir, in the process, sir.
Correct.
Sir, Bala, yes, sir. I'll just add to that to say that because in addition to all the problems that you just now nicely highlighted, and for the sake of Dr. Padi also, sir, more
Yes, sir.
importantly, you see, we also have a lot of people turnover. So the skill set retention is the challenge. And like Dr. Kamath said, because the volumes are low, and at least in the steel case, that is not the case. But over a period of time, you have to maintain. Now, at the plant level, people who have understood and mastered the technology to solve the flatness, waviness kind of problems that you said, or even occasionally not meeting the required properties, because we have actually gone through this. We have developed a recipe and master chart because I myself was involved in this project very closely for more
Yes,
than
sir.
2 years, right? So, but if the right people have retired or superannuated or got transferred to some other plant, I think that would be the biggest challenge in plants like Rourkela, because you see, the knowledge is existing only with a very few individuals, and we again don't have. This is true of our labs also. I don't think that I'm talking only about your industry. That some very senior, experienced people with 35 plus years suddenly superannuates, and suddenly there has been a gap. Then how to bridge that gap is one of the biggest challenges that we have, because like Dr. Kamath talked about the aircraft carrier or the naval steels, and you supply over a period of 10 to 12 years for the same structure. So the plate that you supplied in the first year and the plate that you supplied in the 10th or 11th year should also have the similar properties and as good properties as each other. So maintaining the quality and reliability is definitely a challenge, and this is what I think Dr. Kamath also highlighted. But the point I wanted to bring in was this manpower skill retention is very important.
Yes, sir. Yes, sir.
Dr. Padis, a simple solution for you is to catch hold of Bala.
Yes, sir. We are
Solve all
always,
your problems.
Sir,
sir,
we are always helping them, sir. That's not a problem.
Sir.
Okay. I'm O. Prabhakar.
Yeah, please.
I retired as a professor from IIT Madras, also an alumnus of this institute. I just have an observation. I don't expect a reply from you. Okay.
I like those type of questions.
I worked due to the enlightened policy of IIT Madras. I worked 2 years as a contractor to NASA Langley Air Force Base. I was involved in the development in a very small way. Like, you know, the proverbial squirrel to Rama. We were developing Ma956 alloy. And it was a continuous development. When Wittenberger was developing the alloy. So each time he develops an alloy, say adding yttrium, is going to change the thermal fatigue. They had a nice plant called Pan Steel Corporation. It's a private company, but they will take over this alloy, make products in the form of wire, plates, and all that, only for research purposes. National Science Foundation and other places will give projects so that they will go and find out what is the fracture toughness of that alloy and feed the data so that there was an intermediate factory available, which will take the thing and the whole setup as you little outdated.
No, I fully agree with you.
The whole ecosystem was developed such a way that material was used. You don't go and use some other alloy. You use Ma956 developed by Pan Steel. NSF will make sure the projects are given. So the whole development has to be streamlined. So we need something in between.
Correct. That's a serious limitation in the country.
I can't go. See, my colleague here developed a Professor Subbarao. He developed a super alloy in our own lab, but it just dies there.
Correct.
It has to go to the next stage. We can't go to a big company and say you make use of it. We need something in between.
So
Neither R&D nor industry, but to perform the ala marriage between the two.
fully agree with you.
That's
So
not
this
because
is a
You are in a
pet
very good
peeve of
position.
our director DMRL. He has been advocating this intermediate scale pilot plants for all materials. We have recommended to MOD also. He was a part of a
Tata
committee.
started it in Bangalore, I think.
Correct. But unfortunately, it has not yet happened. But I am hopeful that it may happen over the next 3-4 years.
You are in a position. Do it.
It's not that powerful a position when you
Presented to good. Congrats. Good. Nice.
Thank you.
Thank you. We will close the questions now in crisis of time. Thank you so much for the discussion once again. And we again thank Dr. Samir Kamath and express our sincere gratitude for gracing us with his invaluable insights in today's lecture. Sir, your expertise and dedication to the field of defense research has enlightened all of us truly. As a token of appreciation, I now invite our HOD, Professor V. Subramanya Sarma, Head of the Department of Metallurgical and Materials Engineering, IIT Madras, to present a memento to our esteemed speaker. Thank you so much, sir. As we draw towards the conclusion of today's enlightening session, I would like to call upon Dr. Satyesh Kumar Yadav, Chairman of the Indian Institute of Metals, Chennai chapter, to express our heartfelt gratitude to all of us who have contributed to the success of this event.
Ladies and gentlemen, on behalf of Professor EGR Memorial Lecture Organizing Committee and Department of Metallurgical and Materials Engineering, I express my deepest appreciation to our esteemed speaker, Dr. Samir Kamath, for very motivating lecture. I extend heartfelt gratitude to our chief guest, Professor V. Kamakoti, Director, IIT Madras. I would like to thank Mr. Satish Pai, Professor B.S. Murthy, Professor Subramanian, Professor Kamraj for leading the organization of the event. A special mention goes to Dr. Rohit Batra and members of IIM Chennai chapter, whose hard work behind the scene ensured that everything ran smoothly. I would like to also extend our gratitude to all the volunteer students, especially Jaslyn, MME staff, and ICSR staff whose collective effort has made this event possible. Your dedication and support has been instrumental in this success. Last but not least, we are grateful to each of you for gracing us with your presence today. Your participation and support has been invaluable. Thank you.
Thank you so much for the vote of thanks, sir. And lastly, let's all rise for the national anthem.
Sindh, Gujarat, Maratha,
We can be seated. As we prepare to bring this remarkable event to a close, I extend my sincere appreciation to each and every one of you present here. Let us continue to foster the spirit of sharing knowledge as we strive towards greater advancements in the field of metallurgy. We have highly arranged for all of us in the annexed dining hall. Please indulge yourself. And once again, I thank you all for joining us today. Have a wonderful evening ahead. Thank you.